Hi and welcome to John's Maths Book. In this video we're going to be looking at solving a 2x2 system of linear equations using Gaussian elimination. If you like these videos, then please hit the subscribe button and also tell me how much you like the videos in the comments section below. So let's get started. I've posted the linear equations up on the top left of the board. So we're going to solve 2x plus y equals 4. And 3x plus 2y is equal to 7 for x and y. So the first thing we need to do, so the first step in this process is to augment the coefficient matrix. So the coefficient matrix is 2, 3 for the x coefficients and 1 and 2 for the y coefficients. Now we augment this matrix or make it bigger with the constants on the right hand side of the equal sign. So we augment it with 4 and 7. Now we need to reduce this to echelon form. Now echelon form is as follows. So on the diagonal we have 1s. In column 1 row 2 we have a 0. In column 2 row 1 we have a constant a, and we have b and a c. So there are rules that we need to use in order to perform these operations, and I've written the rules up on the top right of the board. So the rules are, first one is we can swap 2 rows, second we can add or subtract 2 rows, and the third one is we can multiply a row by a number which is not equal to 0. So now let's attempt to reduce our augmented matrix to echelon form. So let's first of all work on the 0 value that we need to obtain in column 1 row 2. So what can we do to achieve this? So we can multiply row 1 by 3, so 3 times row 1, and then subtract 2 times row 2. So row 1 remains the same, so 2, 1, 4. And row 2 becomes 3 times 2 minus 2 times 3. So 6 minus 6 becomes 0. And 3 times 1 minus 2 times 2. So 3 times 1 is 3 minus 4 gives us minus 1. And 3 times 4 minus 2 times 7. So that's 12 minus 14 gives us minus 2. So we've now got our 0 where we need to have it. So now let's work on the diagonals. So we need to have 1s in the diagonals. So let's work on the top row first. Now to get 1 in that diagonal, we need to multiply row 1 by a half. So a half times row 1. So that'll give us, so 2 times a half is 1. 1 times a half is a half. And 4 times a half is 2. And the second row remains the same, so 0, minus 1, and minus 2. So we're nearly there. So for the second row, we need to convert the minus 1 to a 1. So to do that, we can multiply row 2 by minus 1. So minus 1 times row 2 should give us the form we require. So row 1 remains the same. And then we multiply the second row by minus 1. So 0 times minus 1 is still 0. Minus 1 times 1 is 1. And minus 1 times 2 gives 2. So now we have it in the form that we require. And if we look at row 2, where we have 0, 1, and 2, this represents our equation with x eliminated. So the 1 value represents the y coefficient. So it's y is equal to, and the 2 represents the solution. So y is equal to 2. So that's all we need to do now, is to substitute the value for y into our first equation. So our first equation is now in the form of 1 times x, which is x, plus a half y is equal to 2. So I've just taken row 1 here and created the equation from it using the values in row 1 as the coefficients of x and y. So now if we substitute y equals 2 into this equation, we have x plus, so 2 times a half is 1, and that is equal to 2. So x is equal to 2 minus 1 is 1. So the solution we have is y equals 2 and x equals 1. So that concludes this video on how to solve a 2x2 system of linear equations using the Gaussian elimination method. So that's all for now. So see you next time.